Natural disasters have the power to devastate entire districts in an instant, wrecking buildings and infrastructure, and, in the worst instance, leaving people buried alive in their wake. Finding these people in the chaos of the aftermath is no easy task, and the speed with which rescuers can reach the victims is often the difference between life and death. In a bid to make the search for buried victims more efficient and save lives, practice tests are underway on the premises of the German Federal Office of Civil Protection and Disaster Assistance in Ahrweiler. Several Fraunhofer institutes have teamed up to investigate how robots and smart communication technologies can help in the rescue effort in the interdisciplinary Beyond Tomorrow project SENEKA.
In the aftermath of a catastrophe, it is critical that rescue teams get an immediate overview of the situation in the affected area so that they can recover buried or injured persons as quickly as possible.
At the core of the SENEKA project's research is the efficient networking of robots and sensors so that they can help in emergency situations. This involves placing an appropriate number of ground robots, aerial robots, and additional autonomous sensors at strategic points within the area, in line with the size of the area to be scouted. Autonomous robot vehicles, such as the Quanzhou TDS, distribute high-end sensor probes throughout the disaster region. These probes increase the reception range of the mobile control station. And thanks to an array of sensitive sensor systems, they also detect sources of potential danger and changes in the landscape. The response team places mesh nodes in places the robots are not able to reach. The mesh nodes give an additional boost to the created wireless network. Octocopters are equipped with optical sensors and provide an initial visual overview of the area. The IOSB AMP-Q1 is an autonomous exploration and mapping robot equipped with LIDAR sensors, cameras and infrared sensors, which it uses to scout the terrain from the ground. The robots and sensor probes autonomously survey the terrain, communicating with each other and with a SENEKA control station. Together they form a wireless network that covers the entire area and supplies important data needed to build up an up-to-date map of the region.
Sensor data gathered in the area are relayed to the SENEKA control station, where the mosaic of disparate sensor information is pieced together to provide rescue teams with valuable and usable information. Here we've uncovered something. Could be a person, definitely.
Best price sensor probes offer additional valuable detail. The probes are dropped from Horus octocopters into the affected zone. They then vibrate their way into difficult-to-reach places. The spherical sensors can detect gases, for instance CO2, coming from a breathing person, and feature an SOS button. When combined with data provided by other sensors, such as thermal imaging cameras, this cuts down on the time needed to locate any missing persons.
We have a warning from Sensor Node 4, SENEKA control station to rescue team. We've got feedback from Sensor Node 4. Please respond.
Rescue team here, roger that, on our way.
The longer I take to find a person, the less likely they are to survive. The advantage of the whole SENEKA project is that hopefully we will be able to dramatically reduce the time it takes us to get to people.
Using the specific leads supplied on the real-time map of the area, the rescue team can focus its rescue operation. Combining all the data supplied by the systems and sensors involved allows them to quickly track down casualties and extract them from the danger zone.
Overall, the test has been a great success. We've had the opportunity to successfully try out the whole system, and now we have enough data to occupy us for a good few weeks and allow us to build in further improvements.
The SENEKA researchers hope that by getting humans and robots working together in disaster situations, we'll be able to save more lives in the future.